Hello wonderful people, it's Medicosis Perfectionalis. Welcome back to my physics playlist. In previous videos we've talked about how to read physics graphs. We've talked about physical quantities, physical measuring units. We talked about scalars versus vectors. We talked about distance versus displacement, speed versus velocity, and acceleration. Today we'll talk about equations of motion, kinematics in one dimension. We'll talk about how to relate displacement, velocity, time, and acceleration together. As always, every lecture is loaded with questions and problems. So, grab a blank sheet of paper and let's see how many questions you'll answer correctly. Click the like button, click the subscribe button, and let's get started. This video is part of my physics playlist. Try to watch the videos in this playlist in order. The first equation that we'll learn today is as simple as a herpes simplex. So, of course, you know that speed equals distance over time, but velocity equals displacement over time. So, here is displacement and here is time. Amazing? Yeah. Cross multiplication will give me displacement equals velocity times time, or d equals vt, and this is the first equation that you'll learn today. Each equation has its own graph, so how can we graph this relation? Velocity is displacement over time. Easy, you bring a graph like this, okay? The most important question is what's on the y-axis and what's on the x-axis. On the y-axis, I have the change in displacement in meters, and on the x-axis, I have the change in time in seconds. So what is delta d over delta t, please? That is called velocity. So the slope of this line, rise over run, delta d over delta t, is velocity. So the slope of this line equals velocity, and that's the first equation. There is another equation that you can play with that we say delta displacement over delta time. Let's just call the displacement this time, let's call it x. This is the same thing, same exact displacement over delta t, which means velocity equals the change in displacement over the change in time. What is the change in displacement? It is the final position minus the initial position over time. Cross multiplication, please, and you have the final position minus the initial position will give me v times t. We can kick the gluteus maximus to the other side by changing the sign into positive. So we have the final position equals the positive initial position plus v times t. And this is another equation that you can derive from this nonsense. Since v equals displacement over time, therefore displacement equals velocity multiplied by time. If you're not so good at cross multiplication, just multiply each side of the equation by time. So this becomes vt and this becomes just d. Next, the second equation is as simple as tuberosa adiposis simplex. What the flip does that even mean? Well, tuberosa means something tapered and elongated. Adiposis means something fatty, and simplex means something simple. Use your imagination. You know that speed equals distance over time. You know that velocity equals displacement over time. And you know that acceleration is the change in velocity over change in time. Therefore, the rate of change in distance is called speed. The rate of change in displacement is velocity. And the rate of change of velocity is acceleration. You see this equation right now? Yep. Which means what? It means that acceleration is the change in velocity over the change in time. What do you mean by change in velocity? I mean final velocity minus initial velocity. Initial velocity could be called v sub I or v sub 0. Over the change in time, okay. Cross multiplication once again, and you have velocity final minus velocity initial equals acceleration multiplied by time. We can kick the gluteus maximus to the other side by changing the sign into positive, so you have final velocity equals vi with a positive sign plus at. So the final velocity equals initial velocity plus acceleration multiplied by time, and that's the second equation for you. Each equation deserves a graph. You see this right here? Yeah, can you graph it? Sure. So I have my x's, right? What's going to be on the y-axis? The delta v. And what's going to be on the x-axis? The delta t. Amazing. And what's the slope of this line then? The slope is always rise over run, which means delta v over delta t, which is what? Delta v over delta t is acceleration. So the slope of this nonsensical line right here is acceleration. If velocity is measured in meters per second and time is measured in second, therefore acceleration is meters per second or meters per second squared. This is what happened to SpongeBob's pants. They got squared, which means any negative was eliminated. No pun intended. So there you go, the same thing in colors. Acceleration is delta velocity over delta time. Therefore, what does delta V even mean? It means final velocity minus initial velocity. Cross multiplication, please. You have final velocity minus initial velocity equals acceleration times time. This way times this way. Since A always has a 1 underneath, so you can multiply Vf minus V0 times 1, which is this, and you multiply A times T, which is this. Now kick that butt to the other side by changing the sign from negative to positive, and you have final velocity equals initial velocity plus A times T. In lecture 1 in this playlist, I've told you that if you have two entities that are divisible by one another or subtractable from one another, the relationship between them is directly proportional. However, if you have two entities that are multiplied by one another or added to one another, the relation is inversely proportional. Now you know from common sense that acceleration is delta V over delta T. Look at this thing, delta V over delta T. Delta V divided by delta T. Oh, these are two entities divisible by one another. Yeah, hence V is directly proportional to T, which means if V goes up, T goes up as long as A remains constant. If T goes up, V goes up as long as A remains constant. I mean, think about it. If you're driving your car starting from rest, you're accelerating some more. Let's keep the acceleration constant at 2 meters per second. Of course, if I give you more time, your velocity will increase even more. If I come in the first second, your velocity is 2 meters per second. But if I come in that second, your velocity is 4 meters per second. Oh yeah, as time goes up, velocity goes up, provided that acceleration remains unchanged. Graphical representation. Here is A, which is delta V over delta T. Delta V over delta T. Rise over run will give you the slope. What's the slope of this line? This is acceleration. Look, where did I start here? Oh, you started at 0, at the origin. Okay, so here, initial velocity equals 0, which means we can go to this equation and write 0 instead of initial velocity, which abbreviates the equation into final velocity equals AT, because this is just 0. But what if I did not start from rest? What if I was already driving and decided to speed up even more? Oh, so you did not start from 0, you started from a positive number, like 2 meters per second. Oh yeah, that's where I started. Nice, okay? So it's the same straight line going up. The slope of this line is also acceleration. The slope of this line is also rise over run, or delta V over delta T. The only difference between this and this is that this one started from 0, but this one started from something. Why is the straight line going up? Because T and V are directly proportional. When T goes up, V goes up. How did you know that? I mean, look at this. They are divisible by one another. When T goes up, V goes up. That's why you draw your line straight going up. Why going up? Because when T goes up, V goes up. They are directly proportional. Why a straight line? Why not a curved line? Because this is a uniform relation. Next, the following equation is as simple as carcinoma simplex. You know that V equals D over T. Yeah, velocity equals displacement over time. Perfect. What is average velocity? Average velocity is total displacement over total time. Okay, so we know that. Here is the first equation for you. All right, what else do we know? We know that the average of anything is the first number plus the second number over their number. Here is 1, here is 2, so you divide by 2. For example, if I told you that we have a class, the class contains only 2 students. The score of the first student is 100. The score of the second student is 50. Question, what is the average score for the entire class? Easy, 100 plus 50 over 2, which will give me 75. Brilliant. This is exactly what I did here to get the average velocity. V final plus V initial over 2. Okay, so I need both of these equations. Notice that here I have average velocity and here I have average velocity. If A equals B, and A equals C, then B has to equal C, which means D over T from this equation has to equal V final plus V initial over 2. See, physics is very simple. Not everything has to be as complicated as your past relationship. So what do we do right now? We bring an equation that we already know. Okay, we have deduced that V final equals V initial plus A times T. We just said that 5 minutes ago. Okay, you see that V final? Yeah. How about we put this in place of this? Sounds like a good idea because this is V final and this is V final. So D over T equals V final, I mean V initial plus AT plus V initial, because this is the same V initial. You can call it V sub 0 or V sub I, it's the same thing. Over what? Over 2. Let's simplify this nonsense. You have V initial plus V initial. So 2V initial plus AT over 2, okay? 2 divided by 2 is 1V initial, amazing, plus what? Plus half AT, all right? Sounds like amazing. And all of this nonsense equals what? Equals D over T. So D over T equals V initial plus half AT. What if I want D alone? Let's multiply each side by T. So displacement equals V initial times T plus half AT times T, or T squared. And this is the equation that we need to learn about now. If the average velocity is total distance over total time, and the average velocity is also V final plus V initial over 2, therefore this equals this, all right? And then what? I know that V final equals V initial plus AT. So let's put V initial plus AT here in place of V final, and then you simplify, and then you divide by 2, and then you just multiply each side by T to give me displacement alone on one side. Please remember that displacement over time equals V initial plus half AT, which means that displacement is divisible by time. If displacement is divisible by time, therefore, the relationship between them is direct. They are directly proportional to one another. If I give you more time, you will traverse a longer distance. Graphical representation of this nonsense. To keep it simple, we'll say that we'll start from rest, so V0 is 0, which means all of this is 0. So let's simplify this. I have displacement equals half AT squared. Okay, let's divide each side by T squared. So you have D over T squared on one side and half of A on the other side. Okay, these are divisible by one another, all right, which means what? They are directly proportional. If T squared goes up, D goes up. Oh, like a straight line going up. That's what directly proportional means. Now, what's the slope of this line? Okay, the slope is always rise over run. So the slope of this is D over T squared. What is D over T squared? Half of the acceleration. So the slope of this lovely line equals half of acceleration, or you can say A over 2. It's the same exact thing. The next equation is as simple as cystoma serosum simplex. Don't worry, it's just a simple mass filled with serous fluid. Who else is gonna teach you like this? Your professor with his PowerPoint? Give me a break. What do we know about velocity? We know that velocity equals displacement over time. What do we know about displacement? Cross multiplication, baby. Displacement equals velocity over time. This is average velocity. And I know that average velocity equals velocity final plus velocity initial over 2, just like the average score of the classroom. What else do you know? You know that acceleration is delta V over delta T. Let's rearrange this equation. If I want delta T alone on one side, this will equal delta V over acceleration, just like that. Or you can do cross multiplication and then divide by A. You'll get this. And what is delta V, please? Oh, delta V is V final minus V initial. Divide by the same acceleration. And you see this? Yeah, D equals V times T. Here is V and here is T. Let's multiply this by this to get D, because D equals V times T. And I have V, I have T, let's go. So D equals, what's my V? My V is all of this nonsense. Velocity final plus initial velocity over 2. All of this will be multiplied by what? By T, which is acceleration downstairs, velocity final, minus velocity initial upstairs. Let's multiply all of this together. When you multiply the denominator, oh, that's easy, just 2a. Multiply the numerator. This is v final plus v initial, but this is v final minus v initial. You know where that is going. Yeah, v final squared minus v initial squared. Which means displacement equals v final squared minus v initial squared divided by the second amendment. See what I did there? Okay, cross multiplication. D times 2a is 2ad equals v final squared minus v initial squared. Okay, let's get AD alone on one side, just like that, so that it becometh the year of the Lord. This will be v final squared minus v initial squared divided by 2. And this is the equation that we need. And here's the same proof in color. You know that D equals VT. Now you know that V equals this, and you know that T equals this. You just multiply V times T, just like that, and you end up here. The year of the Lord equals v final squared minus v initial squared, the beginning of time and the end of time. Divide by 2 to get the average life that you're living. By the way, you can download these colorful, wonderful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Alright, graphical representation. We know that 2AD equals V final squared minus V initial squared. Okay, then what? Let's suppose that we start from 0. Okay, so I'm gonna make this nonsense 0. So let's simplify. 2AD equals V final squared. Let's divide each side of the equation by D. So what do you get? I get 2A on one side and I get V final squared divided by D. Okay? So here is v final squared divided by t. Rise over run. Here is the rise, here is the run. Here is the rise, here is the run. Okie dokie. And if two entities are divisible by one another, what does that mean? It means that the relation between them is directly proportional. As d goes up, v squared goes up. Which makes sense. If you're driving faster, higher v squared, you will cover a longer distance, higher displacement. Okay, now what does the slope of this line represent? The slope is always rise over run. Okay, what's the rise? It is v squared. And what is the run? It is displacement. Okay, what is v squared divided by displacement? It is 2a. So the slope here is the second amendment. But remember, in the previous story, the slope was half of acceleration. But here it's double the acceleration. So let's put all the graphs together. For this equation, v final equals v initial plus at. Here is the slope. What does that slope represent? It is delta v over delta t, which equals acceleration. So the slope here is acceleration. How about here? This represents the equation displacement equals v initial times t plus half at squared. All right, the slope here is what? It is d over t squared, and d over t squared is what? Half of the acceleration. How about here? 2ad equals v final squared minus v initial squared. What's the slope? V squared divided by d, which equals what? It equals 2a, so the slope here is double the acceleration. Look at the graphs. If you do not see 2 here, do not say 2a. But if you see 2 here, say 2a. So here are the equations, okay? But they require some modifications, because if the question said that the object started from rest, okay, if it's from rest, the initial has to be 0. So you can put 0 here and simplify the equation. Instead of saying v final equals v initial plus at, this is 0, so v final just equals at, because this is nothing. Same thing here. If v initial is 0, this entire thing is 0, so you just can simplify the equation. How about here? If v initial is 0, okay, this is nothing, so you simplify the equation. But what if the question told you that the object started as moving, but then decided to stop later? So v final is 0, okay? So instead of this, you put 0 and rearrange the equation. In the second equation, there is no v final, so there is no simplification here. But here, you put 0 there and you rearrange your equation. But what if the question said the object moves with uniform velocity? Uniform velocity means what? Meaning I'm neither accelerating nor decelerating. So a is 0. So you put 0 here and simplify. You put 0 there and simplify. You put 0 here and simplify. This table will help you crush every problem you'll encounter. You will cruise through physics like a sharp knife through warm butter. And here you have the 3 equations. This equation relates v final to time. This equation relates displacement to time. And this equation relates v final and displacement. But how about acceleration? No, acceleration exists in all of them. So let's say that I know my displacement and I know my time, but I do not know the final velocity. What should I do? You can use this, or you can use this to arrive at this. What if I know v final and v initial, okay, and I know displacement, okay, but I do not know the acceleration? Well, it's here. You can use this equation. Because if you know this and this and this, you only have one unknown. Now let's practice what we preach. An airplane lands on a runway at a velocity of 162 kilometers per hour and it decelerates uniformly at 0.5 meters per second squared until it stops. How many seconds does it take for the airplane to stop? Please pause and try to answer this yourself. Okay, I don't like this, kilometers per hour and seconds. So let's change kilometers per hour into meters per second. And how do you do this? Well, if you don't have time, you just multiply by 5 over 18. So here's kilometers per hour. You multiply this by 5 over 18. And you will get 45 meters per second. What is that? This is the velocity. Is this initial velocity or final velocity? Well, eventually I'll stop. So v final is 0. V initial is this nonsense. So let's write this down. V initial equals 45 meters per second and v final is nothing. Now, do I know my acceleration? Yes, but you gotta be very careful. They said what? It decelerates. So the acceleration has to be a negative number. Negative what? They told me 0.5. So negative 0.5 meters per second squared. I know vi, I know vf, I know a, but I do not know t. So t is the unknown. Therefore, which equation should I use? I know v final, I know v initial, I know acceleration, but t is unknown. Oh, it's here. It's here. If you know v final and you want t, you will use this equation. V final equals v initial plus at. V final equals v initial plus at. Where is my v final? It is 0. Where is my v initial? It is 45. And the a is, careful, it is negative 0.5. And then you multiply that by t. Let's get this negative half t to the other side with a positive sign. So this becometh half of t equals 45. How do I get t alone? You divide each side by 0.5. So t equals 45 divided by half. Anything divided by half, it's as if anything multiplied by 2. Because this is 45 divided by 1 over 2. The 2 goes upstairs, equals 45 times 2. 45 times 2 equals what? Equals 90. 90 what? Seconds. If velocity is in meters per second, acceleration is meters per second squared, then your time will have to be in seconds, so the final answer is 90 seconds. And here is the same answer in color. Next problem. A car moves according to the relation d equals 15t plus 10t squared. Find the initial velocity and the acceleration of the object motion. Please pause. Now, how can we solve this? Look at this equation carefully. D equals something t plus something t squared. What does that look like? Gee, I wonder which one. Of course it's this one. D equals something t plus something t squared. Now this question becomes so basic that the pH is starting to rise. See, all you gotta do is to write both equations under one another. Here is 15t plus 10t squared. And this looks like what? It looks like d equals v initial t plus half a t squared. Okay, who's next to the t? This is what's next to the t. And who's next to the t squared? This is what's next to the t squared. So therefore, v initial equals 15. 15 what? I'm gonna go with the standard unit, meters per second. And half of a is 10. Now think about it. If half of a equals 10, then a itself equals what? You multiply by 2, you get 20 meters per second squared. Easy peasy. Here's the v initial, which is the initial velocity that they wanted, and then the acceleration of the object in motion is 20 meters per second. If you're super sophisticated, you can say positive 20 meters per second squared to tell your teacher or professor that you understand that acceleration is a vector with a direction. And here is the same answer in colors. You put the two equations under one another and then you go to town. Next, Jack drove a car at constant velocity of 30 meters per second. Out of the blue, he noticed a kid crossing the street and he slammed his brakes suddenly. The car decelerated uniformly at 9 meters per second squared until it stopped. Find the displacement in meters. I hope they mean the displacement of the car, not the kid. Otherwise, that will be a terrible outcome. How can we solve this tragic case? So, constant velocity of 30 meters per second until it stopped. Okay, so what is my V final? V final is 0, of course. And what is V initial? V initial is 30 meters per second. And what is the acceleration? Please do not say 9. No. The doofus, Jack, was decelerating, so it has to be a negative sign. Negative 9 meters per second squared. And what do we want? We want displacement. So I have the V initial, V final, acceleration, and I want D. Which equation should I use? Well, I have VI, I have VF, I have A. But do I want T? No, I do not have T, and I do not want T. So forget this. All right, how about this one? Well, this one will give me D if only I know T, but I do not know the time, which means I cannot use this because it will have two unknowns. How about this one? I know V initial, I know V final, I know acceleration. The only unknown is displacement. So let's use this one. So there you go, 2AD equals V final squared minus V initial squared. What is my V final? It is 0. So let's rearrange this. 2 times acceleration, which is negative 9. And what's the displacement? No clue. And what is V final? That's 0. V initial is 30 squared. Nice. 2 multiplied by negative 9 is negative 18D equals, well, what is 30 squared? 900. Okay, don't forget the minus, negative 900. You can remove the negative with the negative. And now 18D is 900. Therefore, 1D equals what? You divide by 18. So 900 divided by 18. If this is hard, make the 18 into 9 times 2. What is 900 divided by 9? 100. So this becomes 100 divided by 2, or just 50 meters, which is the final answer. Displacement equals 50 meters. Hopefully Jack made it in time. Here is the same answer in color. The key point here is that if they say decelerate, do not take their word for it and say, oh, the acceleration is 9. No. It is negative 9 because we're slowing down. If you want to learn about the difference between positive acceleration and negative acceleration, watch my previous video titled Acceleration. Next, if a car started motion from rest and takes time t, which is numerically equal to the magnitude of its uniform acceleration, to reach a final velocity of 16 meters per second. Then the magnitude of the uniform acceleration is how much? Is it 2, 4, 8, or 16? So first, let's set up a chart to see what we have. What do we know here? We know that it started from rest, so V initial has to be 0. And what's the final velocity? It's here, 16 meters per second. Okay, do I know anything else? Well, I know that time equals the magnitude of the acceleration. Since they are starting from rest, it means that this has to be a positive number. Okay, so the t equals the a, all right? So we know the a equals t. Now, which equation should we use? Should we use this or this or this? Well, I know V initial, I know V final, I do not know acceleration, I do not know time. I just know that they happen to be equal. So let's use this. V final equals V initial plus AT. Since A equals T, let's make this A squared. All right, what is your V final? 16. And what is V initial? 0. 0 plus what? A squared. And that's the only unknown in this equation. So A squared equals 16, which means A will equal positive or negative 4. All right, is it positive 4 or negative 4? We started from rest and we are speeding up, of course. So it has to be a positive number, making choice B the correct answer. And here is the same answer in color. We decided to use this equation, of course. Next, which of the following graphs represents the motion of a car that has initial velocity, v sub I, and speeds up at uniform acceleration a during time t? All right, okay. Speeding up meaning, well, whatever it is, it has to be going up, not down. So A is incorrect because A implies that the velocity decreases, which means that I'm slowing down, but they want it to be speeding up. So A is incorrect. Question, velocity over time, what's the slope of this? This slope equals acceleration because you know that acceleration is delta V over delta T. And if the line is going down like this, it implies that acceleration is a negative number, which is not true because I'm speeding up. Acceleration has to be positive. How about this? Velocity over time, this is acceleration. All right, is this acceleration a positive number? Yeah, it's going up. Is this acceleration uniform? Oh, heck no, it is not a straight line. It is a curved line. It is a non-uniform acceleration, making B incorrect. Let's try C. Okay, velocity here, time is there. What's the slope of this line? Delta V over delta T, which is acceleration. Is this acceleration a positive number? Yes, it's going up. Is it uniform? Yes, it is uniform. Okay, so how about this? Well, it's still velocity over time, so the slope here is acceleration, which is also a positive number. I'm going up in a straight line, which means uniform. So is it this or this? Well, it has an initial velocity. When they say it like this, it implies that the initial velocity is something, not zero. Here the initial velocity is something and not zero, but here the initial velocity is zero. So therefore, C is a better answer than D. Next, which of the following graphs represents the motion of a car that has zero initial velocity and speeds up at uniform acceleration during time t? Now, quick correction, this should not say distance. The y-axis should say displacement, so I apologize about this mistake. This should be displacement instead of distance. All right, what do we have here? Oh, distance over time squared. Do you remember the equations that look like this? D equals VIT plus half of AT squared. They said that the initial velocity is zero, so you can ignore this part. And then D equals half AT squared. All right, therefore D over T squared is what? Rearrange your equation. D over T squared equals half of A, which means the slope of this line represents half of A. If half of A is going down like this, it means that A itself is also going down. So acceleration is decreasing. This is deceleration. But they want me to speed up, making A incorrect. Let's look at this doozy. Here is distance again, time squared again. So what's the slope of this line? It is half of A. All right, half of A is going up. Is this speeding up? Yes, it is. Is this uniform? No, it's not. Making B incorrect. Let's look at C. All right, what is D divided by T squared? It gives you half of A. So the acceleration of this line is half A. Is it going up? Yes, it's going up, meaning positive, meaning acceleration. Awesome. Is this uniform? Yes, it is uniform. Did this start from zero initial velocity? No, it did not start from zero. It started from here and not zero. Okay, and this means that C is also incorrect. How about D? Distance over time squared, the slope of this line equals half of A. Am I going up? Yes, you're going up, which means positive, which means speeding up. Acceleration, positive sign. Is it uniform? Yes, it is uniform. Did I start from an initial velocity of zero? Yes, I did. So D is the correct answer. How about this? Which of the following graphs represents the motion of a car that started from rest and sped up at uniform acceleration? Okay, so here is displacement over time. What's the slope? Delta D over delta T is velocity. This slope represents velocity. It means that velocity is uniform, constant velocity. But this is not acceleration. This is moving at constant speed, making A the incorrect answer. How about displacement over time squared divided by 2? We know from the previous slide that displacement divided by time squared equals half of A. In order for you to say t squared divided by 2, you have to say divide by 2 on the other side. What is 2 divided by 2? 1. So this becomes just acceleration. So the slope of this line is acceleration. Is this acceleration positive? Yes, it is, because it's going up. Is it uniform? Yes, it is, because it's a straight line. So this one is probably the correct answer, but let's get moving. How about this? Velocity over t squared. Oh, I see what they're doing here. If this were velocity and this were t, velocity over t is what? Just acceleration. if the relationship between velocity and time squared is linear, then the relation between velocity and time alone has to be nonlinear. It will not be uniform, so C is incorrect. And how about this? Velocity squared divided by time squared will not give you acceleration. It will give you acceleration squared. And if the acceleration squared is linear, then acceleration alone has to be nonlinear. So D is also incorrect, and the correct answer here is B. So how to get the slope? Well, you just ask yourself, this reminds me of which equation? I want displacement divided by time squared. Okay, so this one. Here's displacement, here's time squared. And you keep arranging it and rearranging it until you make it this way. I want displacement on the y-axis. I want t squared divided by 2 on the x-axis, and you'll find the slope is acceleration. How about this one? A car started from rest and sped up at uniform acceleration until it reached a velocity v and covered distance d. What's the velocity of the car when it covers distance that equals 2d? Now, if you can pause and answer this yourself, I'll be so proud of you. So how can we solve this? The key is here. There is velocity and there is 2d. Now let's look at the equations. Which one has velocity and 2d? How about this? It has velocity and it has 2d. Amazing. And they said that the car started from rest, so we can assume that this is 0. Okay, now let's use this equation and this graph. So 2AD equals V final squared minus V initial, but V initial here is 0, so forget this. Let's just keep it simple, and let's not call it final, let's just call it velocity, okay? Nice. Now I want you to look at this carefully, okay? So when the distance was D, the velocity was V. Now let's make the distance 2D, okay? So you want to double the distance. All right, so this becomes 2A, and then you multiply by 2d. All right, what did I do to this side of the equation? You multiplied it by 2. So therefore, I have to multiply this side by 2. So this equals 2v squared. Now, before I multiplied both sides by 2, what was v here? How do you get v from under the exponent of 2? You get the square root. So if you want v here, you just have to get the square root of v squared, which will give you v. All right. How do we do this right here? Same thing, you have to get the square root. Square root of whom? Of all of this. Of 2v squared. All right, what's the square root of 2? Well, it's square root of 2. And what's the square root of v squared? It is simply v. Okay, this looks suspiciously like choice B, which is the correct answer. Now, if this is conceptually hard, which it is, let's imagine that the original v was a number. Let's say it was 2 meters per second. And let's just suppose for the sake of argument that the distance was 1 meter. Let's see what's going to happen to the velocity when we cover the distance of 2 meters. Ready? Let's just add numbers. All right, so let's use this equation. 2, all right, what is my acceleration? We have no clue. What is the distance? We'll do it for 1 first. Okay. Equals what? V squared, which is 2 squared. Which means that 2a equals 4, which means I'm speeding up. Acceleration is positive 2 meters per second squared. Now let's repeat the same shebang when the distance is 2 meters instead of 1. All right, so here is 2. You multiply it by acceleration, which is positive 2. Multiply that by d, or this time it is 2 meters. Thank you. Equals what? V squared. I've no idea how much is V squared. That's the unknown. Okay, 2 times 2 is 4, times 2 is 8. All right, 8 equals what? It equals V squared this time. And what is V? Okay, V has to be square root of 8. And what is 8? 8 is nothing but 4 multiplied by 2. What is the square root of 4? It is 2. So it is 2 square root of 2. I want you to look at this. When the original velocity was 2, the second velocity is how much? It is square root 2 multiplied by the original velocity. Got it? This is to convince you that choice B is correct. Okie dokie. Can you write down the mathematical relation for each graph and what the slope in each case represents? Please pause and try to answer this. Let's go. I see here v squared over d. What's the equation that has v squared and d? This is the equation. All right, if you rearrange this, so I want v squared over d. V squared over d. Let's divide each side by d. You get 2a equals v squared over d, which tells you what? V squared divided by d, that's the slope, which equals 2a. Remember, when you see on the y-axis v squared, take that 2 and put it next to the a. So it becomes 2a. How about this? I have distance divided by time squared. All right, so I use this equation because from this I can get distance divided by time squared. And distance divided by time squared is half of a, which means the slope here is half of a. When you see the power 2 here on the x-axis, not the y-axis, you put the 2 underneath the a, not next to it. Third, here is displacement over time squared divided by 2. It's the same equation, you just keep rearranging it and rearranging it to finding out that this slope has to be a. So this is the same equation as this. Why did I cancel out v initial? Because I started from 0, so v initial has to be 0 in each one of these cases. How about here? I need v squared and 2d. This is the only equation that has 2d. I will cancel v initial because I started from 0. Rearrange your equation, please, so that you get v squared divided by 2d. Guess what? The slope has to equal a. And how about this one? Here is v, here is t. So I use the one that has v and t and tells me the difference because v initial here is not 0. So I'll use this equation. And of course, you know that delta v over delta t is a. So the slope here is double the acceleration. The slope here is half acceleration. The slope here is acceleration. Same thing here, same thing there. The difference is that here I started from 0, from rest, but here I did not start from rest. See what happens when you take your time to think and get your head out of your sphincter? Coming up next, a driver was moving at 80 kilometers per hour when he saw a red traffic light at 100 meters away from the car. He applied the brakes and decelerated at 2 meters per second square. Question 1. Would the car cross the traffic sign or the red light? 2. Calculate the time taken by the car to stop. Please pause and try to answer this. All right, where do I start? By writing down what I know. Moving at 80 kilometers per hour, this is nonsense. This needs to be converted to meters per second. How do you do this? You multiply by 5 over 18. And this will give you about 22.2 meters per second. He saw a red traffic light at 100 meters away. You might be tempted to use this as your distance. No, that's not your distance because I do not know whether he will stop at 100 meters, less than 100 meters, or more than 100 meters. So the displacement for me is still unknown. What I do know that he will eventually stop, right? So his v final has to be 0. And I know that he decelerated at 2, so acceleration has to be negative 2 meters per second squared. Okay, let's start by answering the second part first. All right, so I have v initial, I have v final, I have a. And I have the equation that says that v final equals v initial plus a times t. What is v final? It is 0, so 0 equals v initial, which is 22.2, plus a, which is negative 2, times t. What is the t? That's what I'm trying to find out. You can swing that to the other side with a positive sign so that 2t equals 22.2, so that t equals 11.1 seconds. And that's the answer for the second half of the question. How about the first half? Would the car cross the traffic sign? What do I need? I need displacement. Well, I know an equation that looks like this. 2AD equals V final squared minus V initial squared. All right. What is 2? It is still 2. And what is the A? Negative 2. What is D? D is the unknown. And what is V final squared? 0 squared is 0. And minus V initial squared. So it is 22.2 squared. So negative 4D equals negative 22.2 squared. You can cancel the negative with the negative. Do your math, you'll find that D equals about 123.2 meters. All right, now let's look at this. This is how long it's going to take him to stop. All right, is this greater than 100 or less than 100? This is greater than 100 meters, which means he's not going to make it. And yes, this car will cross the traffic sign. And here is your homework. An object is moving according to the relation this. Please find the initial velocity, its acceleration, and the time needed to stop. Let me know your answers in the comments. You will find the actual answer key in the next video, which will be titled Kinematics Review, a review on motion in one dimension. Get your pen and paper and write these three equations down. Well, let's make them four. If V equals d over t, then d equals vt. This is very important. Also, we learned today that v final equals v initial plus a times t. We learned that displacement equals v initial t plus half a t squared. And we know that 2ad equals v final squared minus v initial squared. You can also write this down as ad equals v final squared minus v initial squared over 2. And here are the three equations once again. Please take a moment to pause and review. If you know time, if you know acceleration, if you know the initial velocity, and the only unknown is d, you use this equation. I know this, but I want that. And here are the equations again with the special situations. You can abbreviate the equations to save time on your exam. Pause and review. You can download my physics notes, general chemistry notes, organic chemistry notes, biochemistry notes, physiology notes, anatomy notes, all kinds of notes on my website, medicosisperfectionalis.com. I help you learn, understand, and pass exams. Check out my other playlists as well. If you found this video to be helpful, please consider supporting my channel by buying me a coffee. Go to buymeacoffee.com/medicosis. Thank you. To learn about your kidney functions, GFR, what happens in the proximal tubule, loop of Henle, distal tubule, and more, download my kidney physiology course at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine, chemistry, and physics make perfect sense.